So they just gave us a graph. They didn't give us the actual function. And it's probably easy. Our goal is to find the largest possible delta to make this true. So what this is saying is the distance between x and the x value of 3 needs to be less than some delta. Okay, so how far can x go around this number x equals 3? So right here, how far can we go to the left or to the right of x equals 3 in order to get delta? That's what the absolute value does for us. You know, the left or the right, it's the absolute value, so we take care of the negative sign. Okay, so to figure out what possible delta is allowed, look over here. It says the y value, if you add 4 to it, it needs to be less than 1. So in other words, that's saying the difference of any y value in the function and negative 4 needs to be less than 1. I wrote it with subtraction notation because this is saying, compare the y values with the number negative 4. And if it's the absolute value, it's saying you have to be within one y coordinate from negative 4 in order to make this statement true. So here's where y equals negative 4. Looks to be around right here in the graph. And this statement says you can be 1 above or 1 below y equals negative 4. So y equals negative 3 would be the next space above. And if I make a hash mark on where we reach y equals negative 3 on our graph, looks to be about right there. And then y equals negative 5, that looks to be about maybe right there. Those are the places that make this statement true. For our y values of our function to be less than 1 y coordinate away from negative 4. So that's x equals 2 and x equals 4. Those are the x coordinates where that happens. But look, you start on x equals 3. You can only be 1 unit to the left or 1 unit to the right. So that means the distance from x equals 3 can only be 1. That's the biggest possible value for delta that satisfies, that makes this statement true.